Hello guys, in the second tutorial of this sequence for object-oriented programming for beginners, I wanna show you the static elements of the class. In the previous tutorial I showed to you the six elements of the class, and we said that the class is the blueprint which we give to construction builders, and they build our objects in our program. And the program actually consists of objects which interact between each other. As the opposite, I could say the structural programming. In the structural programming, actually, the program consists by methods which interact between each other, functions. Okay, they call each other. Now, I'm gonna set the goal right now. Let's say I want to know how many instances of given class I have instantiated across my entire application. Okay. First idea, which of course is very stupid, each time when you instantiate an object you have to increase one calculator, and I immediately will try this idea. Counter, I'm gonna say equals 0. Each time when I instantiate person of this class, I will say counter plus plus. After that, I again can say counter plus plus. As a owner of this little kingdom, ruler of this little kingdom, I want to know how many servants do I have. Of course, I'm joking, but I hope this will make the things clear. I can say the population of my little kingdom is, and I'm gonna say here 0, and counter the population of my little kingdom is 0. Excuse me if I made some spell mistakes or something like that, so I don't have audience in front of me to correct me or help me, and I'm on the hurry to explain the concepts. I usually represent this show as a cooking show for programmers, so right now we are cooking something. Let me see how many guys do I have in my little kingdom. No wonder he's gonna say 2 instances, he's gonna say 2. That's fine, but okay, so the population of my little kingdom is 2. Okay, that's fine, but very easy I can break this program, because this is a local variable, and also the developers should remember something else. In top of all the things they have to remember, now they have to remember that each time when they instantiate object of a class person, they have to increase one calculator. But I'm going to show you that even this counter is not this counter is not a very good idea. What if I have another clone, another method in my program, static? We'll come to this very soon. Static, I'll say void do something else. Let's say I have a method which I'm gonna declare and define, and I'm gonna do something else. I'm gonna instantiate one person more here in another branch of my program. Let's say I'm gonna create again John, but this time with age 25. And even if I call this method somewhere here, just notice this keyword static. Probably you didn't pay attention of that, but your program, each program starts with method main, and there is a keyword static. Okay, so this main method calls another static method, do something else, and I'm instantiating one person here. and the odds are that my counter is not going to show me the right number of the population. It still thinks that there are only 2 persons. In fact, there are 3 persons. I just instantiated one here and do something else. So now I have to invent something much clever. For example, I can send as a formal parameter the counter, which sounds a little bit hopeful, but is not going to solve the problem. So in other words, across the entire application, I have to have a global global variable which counts the number of my persons. This is one possible solution, which sounds to me very stupid and very cumbersome. Or in other words, or another way, I can send across my entire application, always I can drag with me always this counter and send it whatever I think the person will be instantiated. And if there is a new developer in my team and the guy starts instantiating persons, and maybe he will not know about this counter, he is not gonna increase the counter. So let's find something else. We said the object-oriented programming. I'm gonna comment this stupid idea. We said that one of the ideas of the object-oriented programming is to encapsulate all the data necessary to get our job done, including the methods. So let's try to encapsulate the counter somewhere in our class, because the class is the blueprint for our objects. Okay, so let's come here and say public, or okay, let's say public for now. Public, I'm gonna use a field to model this property. Public integer counter. I'm gonna set it to 0. And let's think how this is gonna help us. There are many ideas. For example, this public property I can use with one of the objects, but I end up with the same problem which I had with the counter. I have to drag this concrete instance everywhere across my program. It doesn't matter that the counter actually is not anymore a local variable here. It's an instance variable which belongs to person. So another and there is another problem. I always have to instantiate at least one object of this class in order to access this counter. Okay, so this is one of the problems. What if we count the objects, the instances, by increasing this counter into the constructors? We will play clever here. We know from the previous tutorial that the constructor is pseudo method which is automatically called every time when we instantiate an object. And we have 3 overloaded constructors. Those are the constructors with the same names but different signatures. Those are methods, pseudo methods. And we know also from the previous tutorials that these 2 constructors actually call the very same constructor, which is this one. Okay, let's play clever and say, okay, counter plus plus, and see what happens. Now this is a field into the class, and each time when we instantiate one object, we are calling and increasing this counter. Can this help? Let's try and see. I'm anxious to see. Okay, now I have to call one of my instances. I have person 1, person 2. Notice that I again have to mention one of my instances. So in other words, if I want to say how much is the population of my kingdom, I definitely have to have at least one instance, and I have to say, for example, person 1 counter. It's a field. Let's see what does it say. When we run the program, it's gonna say, oh, we're not 3. I'm alone. There is only one guy. First of all, they don't know each other. Okay, so this counter belongs to person 1. What if we ask person 2? Person 2 is the same situation. It's gonna say again that there is only one person. And this is not the truth. We see that there are 3 persons of the class person. What can we do? Let me draw one drawing. Let me show you one picture right now. Okay, with this circle I represent the set of all objects that can be created, that can be instantiated from the class person. So this is the whole class, and I'm gonna put class here. Those are all objects of the very same class person. Okay, now what do we have? We have one person. I'm gonna try to draw them as similar as possible. One person which is called person 1 and another person which is called person 2. Let's imagine that these variables, these properties, in fact they're like labels on the threads which we attach to each one of these spheres. I told you that you can imagine the objects as spheres, blue spheres, and each one of those labels is very specific. In each one of the labels you can write data which is either string, either integer, double, float, whatever. So this label actually we can use to type the name of this object, and this way we turn this object into Stoyan. Also here we put H. I'm gonna put here the names of the properties which I use to model my person name. Oops. I don't like that, but whatever. So let me draw it again. Okay, this property is name. I'm gonna reduce the size. So this is the label which is called name. This is the label which is age. We have the very same labels, which is very, very important. I cannot create them absolutely the same, but excuse me for that. And this label is called age. This label is called name. They're from different types. This one is string. This one is integer. And again, age here is integer. And this name is of type string. Notice something. All the objects of the very same class have the very same labels. They're even named the same. This label is called name and of type string. This label is called age and integer. This also is age, integer. So they are absolutely the same. What makes the difference between them is the values which we type into these labels. This one we made Stoyan, and we say that this guy is 52 years old. This guy, in the very same label called name, we put it here John. So this is how we actually changed the state. John, excuse me, it's John and it's 20 years old. This is how we actually changed the state of the object. Okay, by declaring this variable, what we did in fact is we added another label which is called counter. Here also, and it is of type integer. It's the same, counter, even though I didn't draw it the same, of type integer. Here we have the very same thing, of type integer. Counter is of type integer. But notice something. Each one of the instances has its own label. What we need actually is a label which is common for all these instances. That's why we have to cut here these threads, keep only one label, and attach it to the entire class. In other words, imagine that you have a drawing on a paper which actually represents a blueprint for a class of houses. Let's say a family house. You can instantiate many of these family houses which are absolutely the same. The only difference between them, for example, is how they have been painted. One of them is blue, another one is black or whatever, red, whatever. But imagine now we put a sticky note on the paper of the drawing, and when we give this blueprint to the builders, we say, hey, listen, each time when you instantiate one house of this blueprint, please on this note just increase the number of the instances. In this case, everything is gonna work. So we need actually a quantum leap. These properties or fields or whatever are instance variables because they belong to each one of the instances. As you can see, each one of the instances has a copy of this label, name and age, name and age, name and age. That's why these member variables are called instance variables, because each one of the instances has own field. All we need is just cut the threads here which connect this label to this instance and move it somewhere here and make this variable class variable owned by the entire class. So each one of the instances has access to this variable, and also all of them own this field. So counter, we need to do it this way. It should look like this. In order to do that, we just have to add static keyword to the declaration of the variable counter, which is a member variable. So let me do something. Here I will say member. I'm gonna talk about them, the variables, the fields, but what I'm gonna say here actually it's the very same for all the elements of the class. Member with a little bit exceptions, which we're gonna discuss probably later. So I'm gonna say member variables. All these age, temp, counter are member variables, but we divide them on two. Age, temp are instance variables because each instance has its own variable, and we also have a class variable. Class variables. Here we go, the example for the class variable. Because this class variable belongs to the entire class, is not owned by any one of the indexes, and at the same time of the instances, and at the same time each instance has the rights to read and write in this variable. Okay, so once we get out of the way the theory, let's see if the counter now is gonna work properly. Once you make actually one element class to belong to the class, you not allow it anymore to put, for example, the keyword this. This is static. Member person counter cannot be accessed with an instance reference. Qualify it with a type name instead. Okay, so we are not allowed to use already the keyword this. And there is something special as well. All non-static elements of the class can access the static elements of the class, but vice versa is not valid. In other words, from a static element, if I try to access non-static element, that's not possible. And we are going to talk about where can we put the keyword static. Okay, now let's see if our program now works properly. Also notice something else. When you declare this field to be static, now it's owned by the class, not by individual instances. So when I try to access, I have to type in C#, notice this, in C#, I have to type the name of the class. In other words, I access the field through the name of the class. In Java, it is possible to use the name of each one of the instances, to access such a static element. In C#, no, that's not possible. I think it's a step ahead. Actually, it's better this way. And you can access the static elements only through the name of the class. So now it doesn't matter where our instance has been instantiated, it's gonna be count, and we will see that now our counter is gonna work properly. Now our counter is gonna show that the population of my little kingdom is 3. We have 3 instances created, is 3. Okay, now let's continue further. Now I'm asking myself, where can I put the keyword static? In front of which of these 6 elements of the class can I put keyword static in front of the class? It turns out yes, you can put the keyword static in front of the class, but this this comes with a price. In this case, you cannot instantiate objects anymore from this class, and the class turns out to be a utility class in which you just put static elements. Each one of the elements of such class should be static. Okay, I'm not gonna discuss this right now. Let's see. We saw that static, the keyword static, can be put in front of the field member variable, and what happens? This field becomes class variable or class field. It's owned by the class, not by the individual instances. Can we put the static keyword in front of the property? Yes, we can. Let's try that. Let's make actually this field private, because right now everybody can access this counter and compromise actually the value which is held here. So I'm gonna say public, for example, static again, static integer counter, oops, and I'm gonna have a getter return counter, because I want to allow the internal world to ask my my class A, how many instances do you have? Get return, of course, return. But I want to protect my counter. I don't want to allow anybody to change the counter. So I can do this 2 different ways. One of them is I'm not going to define setter, which is natural. Or another way to do it is just declare that the setter is private, and here I'm gonna say counter equals value. In other words, only the elements from this class counter can access the counter, because the setter is private. I'll leave it like that for now. Go ahead and read in Stack Overflow, which actually is better. Maybe the better is just to declare private, because As I said, in the setters and in the getters, maybe there are validators and filters for the values, and the values always should be cleaned by the filters and validated by the validators. I shouldn't allow direct access to the field where I'm keeping the value of this property. But as I said, I'm gonna show you both variants, so that's why I'm just commenting this private set. Okay, counter. We can argue a lot, of course, about different things, how they should be done. Okay, so now we saw that the keyword static can be put up front of the property declaration as well. Can we have a static constructor? And just in a second I'm gonna show you that we can, and the static constructor actually it's a very interesting thing. But before that I wanna say that okay, I wanna solve another problem. Let's say I want each one of my persons to be aware about his nationality, and I also want to be able to change the nationality of my persons at once. In this case, this is another example for using a static filter property. In this case, what I'm gonna do is I'm gonna declare again private static string nationality, where I'm gonna keep my nationality. In here I'm gonna say Bulgarian, for example, Bulgarian, and I'm gonna create just for fun property as well, public, which will allow me to set and get the value of the nationality. Public, that's a good example. Of course, if somebody tries to set, for example, nationality which doesn't exist, I will refuse it in my setters and getters. Right now I'm not going to do that, but I can implement filters and validators in the set. So public static I'm going to say, because I want this to belong to the entire string nationality. Please watch this video on watch it 2 times faster, so you're not gonna waste your time. Return nationality, and I'm gonna set here set nationality equals value, and voila. Now let's teach our guys to say their nationality, and I'm gonna say I am, and whatever nationality is, nationality. I'm gonna keep using the fields because in later tutorial, as I said, I wanna set for myself a trap which I wanna fall in and introduce something else, nationality. Okay. Now, when the people in my little kingdom introduce themselves, they're gonna show their nationality. Inaccessible counter, person counter. Yeah, I just changed, as you saw, the field. I made it private, and now I'm allowing the access to be possible only through a property, which is the proper way to do it. I don't even have a setter. Now nobody can say, for example, person counter and set it to something fake. I properly will calculate the number of my little kingdom, the number of the population of my little kingdom. Property independent cannot be assigned to its read-only, blah blah, and so on and so forth. There are of course a lot of concepts I want to cover in this tutorial, so I'm planning to do 2-3 tutorials, not more. So I won't be able, for example, to cover everything. Maybe I won't be able to cover indexers and default or optional formal parameters, params, variable number of parameters, or maybe I'm gonna cover this, but maybe I'm gonna do a separate tutorial about it. But for now, let's stick with the static elements of the class. This is what we are covering right now. So nationality, and Control F5, and the application works. And all of these guys say that they're Bulgarian. Can I change right now nationality? Yes, of course, very simple and very easy now in my program. At once, I can say person nationality equals German, for example. And now when I ask my guys, okay, introduce yourself, they all introduce themselves and say that they are Germans. Okay, this is another way of thinking for the static elements of the class. Okay, I'm just tempted to show you that they're optional parameters, and I'm gonna use one of the constructors. Let's say here my working horse. If I want to send an optional parameter to a function, I could do something like that. Let's say I wanna transfer something temporary. I can say integer temp equals 0. My constructors will continue working. This is an optional parameter. You always have to set a value, and once you start, this is a default value for this parameter. Once you start with this, there is exception of course with C#, in C#, you have to continue again with another optional parameters. I just want to show you that there are functions. In this case, this is a constructor with variable number of parameters. I can say params, for example, params. Let's say in our constructor we want to set the name of the friends of a given person. I could do this like that. String, and I'm gonna say friends. So when I construct people, for example, I can provide an optional parameter, this example for the optional parameter, and I can provide variable number of parameters. What I'm talking about? Okay, let's say when we create our John, we can say, okay, this temporary variable is takes a number of 12, and now I can say, okay, the friend of John is Stoyan, only the names. John, Sean, for example, and somebody else. Now I sent as extra parameters those arguments, Stoyan and Sean. Maybe you're asking yourself, how come console write line can have a variable number of parameters? Here I can put another comma and put another parameter. This is done this way, exactly like that. Okay, so let's prepare one field which is gonna be array private. I'm doing this by purpose. Private, I'm gonna say string friends equals new string. Let's say I can have up to 5 friends. Just for this example, I'm gonna use array. Of course, you can use linear type of data structure. For example, list, and you can have unlimited amount of friends, but right now let's say up to 5 friends I wanna hold in this property, in this field, this element of the class. And here in the constructor I will do this. Let me say integer e. I will need one iterator. I'll say for each string the name of the friend in friends for each for each string friend in friends, and I'll say this friend I equals friend. Okay, in other words, I'm setting the values of the field friends, which is not accessible, notice this, not accessible from outside of the world, because I'm gonna turn this into an indexer. Not gonna go very deep into the rabbit hole. I just wanted to show you that methods can have optional or default parameters or a lot of parameters. Okay, so this is how this works. If I run the program, it should work properly right now, because none of these parameters are mandatory. So I may send a value for temp or not. I may send one friend, two friends, three friends, four friends, or as many as you want. In this case, we will have problem, because if we send more than 5, this array cannot hold it, but that's not a problem of the formal parameter, it's a problem of the field which we have created. Okay, so now how can I access the friends of our guys? In our case, this is John. There is something which a syntax construction structure which is called indexer, and I'm gonna show you how that works right now. If I wanna access one of the friends of John, for example, of course you can add here logic for throwing errors if there is no index, such index which you're looking for. I'm not gonna go into this direction. All I want to show is just optional parameters and variable number of parameters. That's all I want to do, and just showing indexers. So what you can do here is something like public. This is not a part of the tutorial for the static elements. I just recall that I have to cover this, and that's why I'm doing it. Public, I will say public string this integer I. Notice this get return friends I, and set friends I equals value. Okay, so it's a little bit strange syntax. It looks like a property, we're defining a property, but this property actually it's called indexer, and it's gonna allow us to call different indexes for friends the same way as we do for the arrays. In other words, we are gonna use the objects as they were arrays. I'm gonna say person2 give me your friend, that's John, and I'm gonna say console write line the John's friend on position 0 is, and notice now I'm gonna put here one placeholder 0 person1 0. Now I'm gonna get John's friend, which is gonna be, in this case, I don't remember, it's Stoyan, and after that we'll call Sean. Here we go. Where it is, Population, the Jones friend in position 0 is shown. Wow, that's strange. I made a mistake probably here. I usually do that. On position 0, friends, of course, I forgot to increase the counter, and that's why all the friends get saved in index 0. Okay, let's run it now, and it should work properly. Voila. Now everything works fine. So on position 0 there is Stoyan. On position 1 we should have Sean. Okay. Whoa, exception. Exception, okay. Person 2, person 1, John, position 0. Of course, this should be 0 and 1 should be changed here. Like that. Now, the placeholder, I just make a mistake with the placeholder. John friends in position 1 is Sean. Okay, I just will close this topic right now about the indexers, which I just recall that I have to cover in one tutorial, and I will go back to the static elements. So we reached the point when we created two static properties. Just let me help you to recall. It's my fault that I didn't talk about the static elements all the time. I just started to show you something else. Okay, so we said that the static elements, actually the keyword static is doing a quantum leap. It turns the class into something which cannot be instantiated anymore. The keyword static makes a quantum leap also for the fields or other elements. It detaches this field, for example, this member variable, from instances and makes them owned by the entire class. So they become class variables. And we give two examples with the counter, which counts the number of the instances, and also one static field which is called nationality. We said that the keyword static could be put in front of all the elements of the class except body, of course, for which it doesn't make sense. Okay, so we covered the keyword static in front of the field. We covered the keyword static in front of the property, and now we were about to see if we can declare and define a static constructor. Actually, we can. If I say static person, I'm creating right now a static constructor. It's a very strange animal. It doesn't get any parameters. It doesn't have to have any parameters. We use a static keyword. It doesn't use also any access modifiers. It doesn't have a return value as ordinary constructor, like all the rest of the constructors. It could be only one in the entire body of the class, and also it gets called two times, in two cases actually. First, the static constructor is going to be called when I try to instantiate even one object of this class, and there is a second case when the static constructor is called, and this is the case when you try to access one of the static elements. In other words, you may not have even one instance of a given class. The static constructor will be called if you try to access one of the static elements. And just to prove that, let's say nationality, let's set the nationality to something else, Albanian, for example, Albanian. Don't ask me why. Albanian. Okay, let's ask our guys for their nationality. All of them say that they are Albanians, as you can see. Even if I ask in the very beginning of the program my class, and I say console write line, give me your nationality, my nationality, or nationality, is, I noticed something. I didn't instantiate any object from the class person. Now I'm gonna ask my person for its nationality, and you'll see that even though we set it to Bulgarian, it's not gonna answer Bulgarian, it should answer Albanian, because at this moment the static constructor will be called. It's gonna set the nationality to Albanian, and this person will say that nationality is Albanian. Let me see that. Here we go. Okay. Now, while we are talking about the static elements of the class, I'll represent two more concepts. One of them is the constant. I'm gonna say public const, because the constants are always static. That's why I'm including here constants. Public constants, const. Let's say double. I want to redefine the p number. I'm gonna say 3.14 for some reason. What happens here? Whatever we use this p constant, we can access through the class, not through the separate instances. Okay, here I'm gonna say this. I didn't use the static keyword, but it doesn't matter. The constant is always static. I'm gonna say p is, and I'm gonna use here p. Look also how it changes. I'm gonna say p. Okay, this is static element. The constant, in other words, is a static element of the class. It doesn't matter, you didn't use the keyword static. There is something else which I want to explain as well. We're talking here about the early binding. When the compiler starts compiling our program, whatever it meets this constant, the name of the constant, actually it replaces it with the actual value, which means that in the code you won't see actually the variable p, or not everywhere. You'll see the number 3.14. In other words, the name of the constant gets replaced with its value everywhere during the compilation. Now I'm gonna show you something else. I'm gonna say public read only, read only double, read only double, and I will say only read. I'm gonna set the value to 2.7. What about the fields, the variables which are declared with the keyword read only? Read only means that we set the value in the program, but during the runtime, notice this, and compare with the constant. The constant, the value of the constant is set during the compilation. The value of only read variable, because it's declared right as read only, is set only once during the runtime when the program gets executed. So only read, and I will show you that each one of the instances will have a different value for only read. Let me go to the constructor, and I will say, for example, only read equals h multiply by 5.4, for example, 5.4. And there is something special as well. When you set the value of only read here, initialize this variable, and after you do the same in the constructor, the value which is set in the constructor actually prevails. There are only two places where you can set the value for such a variable which is read only, and these two places are: at the same time, when you declare this variable, you have to initialize on the very same row, on the very same line, or another place is in the constructor. If both ways are used to set the value, then whatever you define in the constructor prevails. This is what is important for read only. Okay, so let me ask my guy to print his value only read. Only read. And here I'll say only read equals, and put number 3 as a placeholder. I can put this on the second line so it's seen, and you'll see that each one of the guys has his own read-only value. For Stoyan this is 280.8, for John this is 108. Okay, but once this value is set, and it gets set in the constructor, you cannot anymore change its value. Person 1, and if I say now only read equals 5.6, this is not gonna work, simply because only read could be set only once, either during the declaration, or we can initialize with the value here, or when we construct, during the construction of the object. But this value, as I said, is set during the runtime, not while the compiler is compiling our program, which is the case for the constants. Okay, now, so let me tell you something else. Let's see if the static keyword can be put up front of a method, which is the 6th element of the class. Yes, it can. Public, and I'll calculate, for example, the national income of my little kingdom. Public static double calculate. Of course, this is a fictional calculation. Calculate national income, and I'm gonna say return calculate. Let's say I will calculate the counter, which keeps track of how many instances do I have by value of 10,000. Let's say this is the treasure which each one of my guys has in my little kingdom. So this method belongs to the entire class, because it's using, as you can see, a static element, and I always can turn to this method and ask, okay, how much is the national income of my little kingdom? In the beginning it's gonna say that there is no national income, or it's gonna be 0, and after that, after instantiation of my guys, the population will increase and my national income will increase as well. National income, and I'm gonna say person, and as all of the elements which are declared static, as you can see, national income, calculate national income, is accessible directly through the name of the class. And now it's gonna say that in the beginning of the program that my national income is 0, but I'm gonna call the very same method, which is static, at the end of the program, after instantiation different objects, and it's gonna tell me that my national income actually it's 30,000, because I have 3 persons created here. And here we go. So let me make a short recap. We saw that the keyword static makes a quantum leap for the elements of the class. If we want to make one element of the class class variable or class element, we have to use the keyword static. The element doesn't belong anymore to different instances, it belongs to the entire class. All the instances has access to it, and all instances get read and write. Okay, so now can we put the static keyword at the front of the class? Yes, we can. In this case, we turn this class into the utility class because it turns out to be only a container which contains only the static elements. Usually in these utility classes we put utility methods which are also static for calculating different things. We cannot find the proper place to put these methods in other classes, so we put it in this utility class. Fields, the fields can be static as well. The body, of course, doesn't make sense to put a keyword static. Properties can be static as well. We saw this. We can have a static constructor which is a strange animal. It could be only one, and it's called two in two cases. One of the cases is when we instantiate object of a given class, and the second case is when we try to access one of the static elements of the class. Methods also can be static. So in other words, the keyword static can be put up front of all the elements of the class except the element body. Thank you for your attention.